Right, we are going to get started on our first set of notes for the year, which hopefully is mostly a review for you, but if not, we are going to make sure that you leave today comfortable working with functions, if nothing else. So, what is a function versus a relation? So, a relation is just any subset of ordered pairs, any relationship. And now this relationship doesn't have to just be numbers. It can be students and their teachers. It can be people and their favorite ice cream flavors. It does not have to be numbers to be a relation. Now, what is a function? A function is a special kind of relation where each input has only one output. And our inputs for functions and graphs are going to be our x values, and our outputs are going to be our y values. So a function has only one input per output. So this means that our x's don't repeat. Now, how can we tell if a graph is a function or a relation? Well, we are going to use a method called the vertical line test. And now, remember, vertical just means up and down. So what we are going to do is we are going to draw a vertical line through the graph and see how many times it crosses. So on this first one, it crosses once, twice. So that means that it fails my vertical line test, and therefore it is a relation and not a function. Okay, now on this next one, when I draw my vertical line, it only touches the graph once. So this means that it passes my vertical line test, and therefore it is a function. So the vertical line test, it passes when it only touches your graph one time, and therefore it is a function. Now, how would I determine if a set of data or a set of ordered pairs is a function or a relation? What you're going to do is look at these ordered pairs. Remember, these are ordered x, comma, y. And what you are really focusing on is just your x values. You want to see no repeating x values. If your x's don't repeat, then you have a function. If your x values do repeat, you have a relation. So looking at these, I'm going to look at my first row. For my x's, I have 9, 2, 1, and 0. None of them repeat, so this is indeed a function. Okay. On the next row, I have -9, -9. It's already failed, so this is a relation and not a function. On my next one, I've got 4, -2, 6, 6. I've got 2 6's, so this is a relation and not a function. And on my last one, -2, -1, 8, 8. Again, I have repeating x's, so that is a relation. So your y values can repeat, but your x values cannot. Okay, let's do some practice evaluating functions by hand, or algebraically is another term for this. So when we are evaluating functions, the thing you're going to hear me say a lot is, are we looking for the input or the output? So if you're given x, this is your input. And if we're talking about f of x, that is our output. That is your y value. So on this first one, I'm given my function f of x equals -x minus 5. Solve for x when f of x equals -3. I am here given an output, which means I'm going to be solving for the input x. So I am going to set my function equal to -3 and solve for x. Now this is just a simple two-step equation. You've been doing this forever. Add 5 to both sides. I'm going to divide by -1 to make that positive. Oops, and that should be +2, not -2. And so x is -2. I was given the output and I solved for the input. So f of -2 gives me an output of -3. An input of -2 gives me an output of -3. The ordered pair for that function on my graph would be -2, -3. That would be a point on my graph for that function. Okay, on the next one, I've got h of x is equal to 5x plus 2. Find h of -6. On this one, I am being given the input, which means I am going to input -6 into my function. So everywhere that I have an x, I'm going to replace it with -6. And I'm going to be solving that following my order of operations. Multiplication comes first. Now that I've got -30 plus 2, I can add those to get -28. So h of -6, when -6 is my input, I get an output of -28, which means somewhere on my graph I would have the ordered pair -6, comma, -28. Okay, the last one on this front side, I've got another function, g of x equals 3x squared minus 10x minus 9. Find g of 4. Again, here I am being given the input and I want to find the output. So everywhere that I have an x, I'm going to replace it with 4, and that is in 2 places for this function. And again, order of operations, I'm going to have to square this 4 before I do anything else. Now I can multiply. And I can subtract. So my final answer is -1. G of 4 equals -1, which means somewhere on my graph for that function, I'm going to have a point at 4, comma, -1. Now, all of these functions are written in something called function notation. This is where instead of saying y equals, we say f of x, g of x. That letter in front can be anything, but we're saying when I evaluate it at this x value, what am I getting? That is function notation. And we're just distinguishing that between simply saying y equals. Okay, moving right along. What do I do if I'm, again, evaluating a function with a variable? So here I've got k of x equals x squared minus 3x plus 1. Evaluate k of x plus 1. So what this means is I'm going to plug in x plus 1 everywhere that I have an x. And again, that's in 2 places here. And I'm going to be doing the same procedure I have been doing, but I'm going to have an x in my answer now. So remember, x plus 1 squared, this means x plus 1 times x plus 1, which means you FOIL. So that's going to be x squared plus x plus 1. So x squared plus 2x plus 1 is what you're going to get from that first operation. Then here I have to distribute the -3, so that's going to give me -3x minus 3. That plus 1 does not change. Now I'm just going to combine my like terms. I don't have another x squared. 2x and -3x gives me -x. 1 minus 3 plus 1 gives me a -1. And so k of x plus 1 gives me x squared minus x minus 1. Okay, one more problem evaluating our functions algebraically. Here I have 2 functions, j of x and m of x. I want to find j of 3 minus m of -1. So first I'm going to find j of 3, so that's saying when my input is 3, what is my output? So that's going to be 3 times 3 plus 1, so 9 plus 1, which is 10. So j of 3 is 10. Now I want to find m of -1, so I'm going to input -1 for my x. -1 squared is +1, minus 2 is -1. So m of -1 is -1. Now if I'm subtracting that, that would be 10, because j of 3 was 10, minus -1. M of -1 was -1. Now I have minus a negative, which means this is going to become plus. So 11 is my final answer. J of 3 minus m of negative 1 is positive 11. Okay, the last thing we are going to do to wrap it up today is evaluating functions from graphs. So remember, x is the x-coordinate of your ordered pair. F of x is going to be the y-coordinate of your ordered pair. So again, we are going to first be focusing on, are we looking for the input or are we looking for the output? So if you're asked to find f of x, you're looking for the y value that corresponds with your given input. So for this first one, find f of 5. So that means when x equals 5, what is y? So what I'm going to do is go to my graph for the x-coordinate of 5, and I'm going to find that point on my graph is right here, 5, 7. So when x is 5, y is 7. So that means that f of 5 equals 7, because that's my y-coordinate. Now, what if you were asked this the other way? What if it said, what is x when f of x equals 1? Well, in that case, I am looking for the x-coordinate when my y-coordinate is 1. So I'm going to go on my graph to where I have a y-coordinate of 1, and that's actually going to be in two places here. I've got 0, 1, and 4, 1. Remember, my y's can repeat. My x's cannot. So what is x when f of x equals 1? Well, I have two answers. X can be 0, and x can be 4. Okay, last one to wrap it up today. Find f of 9 for my new graph. So again, this means when x equals 9, what is y? So I'm going to look at my graph. Here is 9. That point is 9, 8. So f of 9 is equal to 8. That's the point on my graph. Now, one more time, I just want you to have practice seeing it the other way around as well. What is x when f of x equals -2 for this graph? So again, this one is asking what is x when my y is -2. So on my graph, I'm going to go to where y is -2. And again, this is happening at 2 points. I've got the point here, -5, -2, and I have the point -1, -2. So my two x values at those coordinates are -5 and -1. So this is what you're going to be expected to be able to do, is not only first determine if you've got a function or relation. That can be with your vertical line test or seeing if your x's are repeating. You're going to be able to evaluate functions algebraically. Again, you could be looking for the input or you could be looking for the output. And lastly, you're going to be able to evaluate functions from a graph. Sometimes you're looking for x, sometimes you're looking for y. And that is going to wrap up our introduction to functions today.